Good evening, everyone. How are you guys doing? 7 o'clock on Tuesday night at reInvent. There we go, that's excitement I want to hear. Yeah, that's right. My name is Amy Che. I'm a Principal Technical Program Manager at S3. I've been with AWS for almost 5 years now. So I'm here to talk to you guys about data lakes. How many of these people in this room are wearing wearables, have a watch, something that sends you like alerts, tells you when to get up, kind of move around, especially when you've been sitting for a long time, and everyone's favorite, it counts your steps, right? And you're in Vegas, and you're going to be getting a lot of steps in. You're guaranteed to get those 20,000 steps in a day. So all of you who said that you have a wearable, you are part of the problem. And this problem that you have is you're generating petabytes of data that you need to store somewhere in the cloud. And so that's why I actually work at S3. We're here to help you with how to store all of your data in the cloud within data lakes. So if you're here to hear about data lakes and some best practice around that, then you're in the right room. So data at scale. Everyone uses this term. They also use the term big data. So what does it actually mean? Big data is generally characterized by the 3 V's. Extreme volume of data. So the data that you're generating from your wearables, sensors, IoT, your SaaS applications, that's a lot of data that you're generating. And also, I mentioned a huge variety of sources, right? So volume, variety, followed by a high velocity of data. This data is coming in, a lot of it might be real-time data, clickstream data that you want to process and analyze and leverage. So all of this data, big data, you want to store within a data lake. And you want to store your data lake in such a way that it can handle your data at any scale. So you'll be hearing from 3 different speakers tonight. I'll be giving you the overview. You'll be hearing from the AppsFlyer EVP, Gilad Katz. He's going to be speaking about how and why they use their data lake. My colleague, John Mallory, Storage Business Development Manager at AWS, will be sharing about performance, best practices, and data lake foundations. And I'll be wrapping up on security. So data at scale. So the data lake is a centralized repository. It stores all of your structured and unstructured data. And you want to be able to store all of it in the raw format at any scale. The data catalog on top of it is a centralized repository. It's your source of truth. It basically holds everything together, tells you where all of your data is, where the sources came from, and who's been accessing it. And then you want to have the integration with your analytics and machine learning on top of it, which is how you're going to be leveraging those business insights. So all of this data is going to be your center of gravity, your source of truth. And so it's going to be used by many teams, people all around your company, around the different lines of businesses, analyzed by different applications for a variety of business innovations. And so because of that, you want to make sure that you store it somewhere that's centralized, that's easy to access and use. And so Amazon's simple storage service should be the foundation of your data lake. So the name in itself says what it is. It's simple. S3 is simple to use, it has consistent behavior, and it's predictable in its operations. So for all of you guys out there who actually does the DevOps, you have to go in and do all that admin stuff, it's great for that. So the native features of S3 is exactly what you would want for your data lake. You always hear about the 11 nines of durability, the high availability, and the scalability, and we'll talk a little bit more about this. We'll be covering some of the security best practices for how it's secure, what you can do to ensure that your data is secure, ensuring that it's compliant with all the data regulations, and that you make sure that your data is auditable. It's highly performant. We have a variety of storage classes for your cost optimization, and it's integrated with the broad ecosystem of not just within AWS, but with all of our partners, ISVs, open source companies. And so you have your data lake for the data catalog integration, a lot of ingest services that you can leverage, and then even more analytics and machine learning on top of that. So now I'd like to hand it over to Gilad to talk about how AppsFlyer uses the data lake.
Thank you. So thank you for hosting me. Thank you for coming to hear us. So I'm going to briefly share some of our experiences using S3 as our data lake. So just a bit about the company. So we've grown significantly since 2011. Currently, we're almost 900 employees. We almost double our size every year. We serve approximately 70,000 different customers with a very high market share. And on the data side, as you mentioned, we all produce a lot of data. We handle approximately 80 billion events a day. So a little bit about what we do. We are a mobile analytics and attribution company. We are actually enabling the ecosystem of app discovery. We are in the middle as an integration partner between app developers, and you see some of the bigger names that are customers, and a range of 5,000 ad networks. And instead of each of these advertisers having to do an integration with each one of the ad networks, we give a simple solution that enables all of this to happen. So we are right in the middle. This makes us a mission-critical service, and therefore, all of the components that comprise of our system have to be very durable and scalable. So just a little bit about our architecture. We can split it into three main parts. One is more of a stream-like service. This is where we handle these 80 billion events. We do in-stream processing, and in almost real time, we do a number of activities like adding this to analytical dashboards, sending it to our partners, once again, to make this ecosystem be able to be efficient throughout all of the things that are happening. The second part is when we persist it, and this is where S3 comes in play. We store approximately 25 teras of data each day. Just on the specific data lake, we have more data that is stored. And then we have pre-aggregation, batch processing, and analytical databases that serves insights and analytics to our customers. So a little bit about S3 at AppsFlyer. So the key requirements for us, and this is we're safeguarding the data on behalf of our customers. So this is important to us and important to them. So of course, it starts with security and privacy. Availability, as I said, this is a mission-critical service. The data has to be accurate. Otherwise, it doesn't matter. It doesn't have value. And the last, it has to be efficient. Think of a company that its traffic is growing approximately 5% a month. So we have to think about efficiency, both for operation reasons and for cost effectiveness. So I'm going to mention just a few of the use cases. So we write, as I said, about 26 teras a day. One of the key services that we give to our customers is the ability to consume the raw data directly on their S3 buckets. So this is something that's really a part of their crucial day-to-day activity. We do, like I said, pre-aggregations for analytical tools, and we support GDPR for compliance, and now also with the California rules. So specifically, how we do the raw data report. So for security reasons, we use a different account than our production account. We partition all of the data in one bucket due to limitations of the number of buckets that you can have in one account. So each customer has its own prefix. We use IAM user access permission schema to do the authorization. And one thing to keep in mind with this kind of approach is that there is a limitation currently of 5,000 users per account. We can always open an account or have Amazon increase this number. So just diving a little bit deep into the schema, so we do the S3 list bucket and the ability to do gets on the objects. Here is where we allow the specific prefix and give it the permission to the specific user. So one of the things that we've been experimenting and trying to figure out what's the best manner in terms of partitioning the data is how to separate it. So we have 70,000 different customers. Each one have at least one app. Sometimes it's thousands of apps. And you have to keep in mind that these apps, due to the way the market works, sometimes change accounts due to acquisitions and so on. So one of the things that has been happening is that the requirement for the data to be ready, whether it's on the analytical databases or the raw data access, is becoming with a higher demand to be closer to real time. So in the beginning, we had these reports being prepared 24 hours, more than 24 hours delays, and then the customers started asking it to be in buckets of 1 hour. So currently, it's being served every hour with a 3 to 4 hour delay. And we are now working on to decrease this latency to have it ready 1 hour from the point that it reached the system. So we are doing it in 10-minute increments of buffering. And we thought about two concepts about how to partition. So the first thing that came to mind is to partition by app. So it's a trade-off between the ease of use and efficiency of reading a specific app when you want to read it for analytical reasons versus what happens when you do cross-app queries and you want to see the broader picture. And so we thought that it would make a lot of sense to partition it by app. What came out of this is the huge amount of files. In general, the total volume of data increased due to the fact that it's less efficient. And we tried to do these queries, and what happened is, and I'll show a graph later that describes the differences, is that it was efficient per app, but the more apps we increased, it became, in the beginning, less efficient and eventually not feasible due to the amounts of files. And when you do the LS, when you list the directories, you get a lot of files. It takes a lot of time, and you can reach out of memory within, for example, Spark driver. One other thing that is good about this approach is that you can use the retention policy rules of S3. The other option was not partitioning by app, just partitioning by time and sorting by app. This is a much more balanced solution. We didn't know if it's going to be effective in terms of when you want to read just one app. And one other caveat is that you cannot use the retention rules that are given by S3. And when you look at this graph, which was very surprising to us, we saw that there was no significant difference. There was no real benefit to partitioning it by a specific app. And you can see what happens the more apps we read. So even when there are very little amount of apps, the difference is really small, and it becomes better and better towards the ordering in terms of decreasing latency. So this is just a little bit of considerations when you want to think about how you partition your data, which is a key thing, especially when you start and when you scale. The last thing I want to talk about is about GDPR. So I'm not going to explain about GDPR. I don't have much time. But we were very eager on supporting this in a very good manner. We didn't know what to expect. We are a processor, not a controller. And we figured out it's going to be between tens to hundreds of requests per month for deletion of user data. Eventually, it was 300,000 and still growing. This is due to different clients acting in different ways. The way we decided on doing it was to build a user index which maps all of the files per user, and then specifically go and rewrite these files according to the request that we are getting. The thing is that as time goes and the data is moved into infrequent access policy for efficiency reasons, what happened is that we're doing a really inefficient move because we are reading the data, so we're paying the penalty for the retrieval cost of the infrequent access. Then we are copying it, deleting the file, and rewriting it. And then it goes back into the policy of having 3 months until it goes into infrequent access. So one of the new features that S3 introduced, which is the intelligent tiering, was really effective because what happens there is that whenever you read the file, it just turns back into standard, and the only thing that you pay is actually the fact that it's not infrequent anymore. And for this use case, it actually created significant savings. So this really, the whole S3 solution really enabled us to grow this fast and to assure that we serve our clients in the best manner possible. So thank you very much.
Thank you very much. Okay, so I'm John Mallory, as Amy said at the outset, storage business development, been at AWS for about 3.5 years, and I want to talk to you about some foundational and some performance best practices. So Amy described, how we define a data lake on S3 or on AWS, with S3 being, really the foundation of the data lake. What I'd like you to think about when you're starting your data lake journey is really modules, and starting to think about, as you architect, think about functional blocks. And this is really akin to, cloud best practices is not a big monolithic stack. It's a collection of microservices, which we obviously embrace ourselves. S3, in spite of its massive scale, is a collection of microservices, as are most AWS services. So obviously S3 is the center here, where you're going to aggregate and store your data. You're going to bring the processing tools to it as much as possible. But you're really going to lay the foundation on top of the data of robust security. So, that's the manage and security block. IAM and KMS are the workhorses there, so that you can start to get coordinated access across your entire stack that you're using, from data to metadata to the applications themselves. You've got a lot of different ways to ingest data. So you kind of want to think of your ingest patterns today, but also think about where you want to go in the future. And then catalog is really one of the most important pieces beyond security of the data lake, in my view, because if you don't have a catalog, you can't perform effective analytics. So getting the data, catalog, getting it transformed and ready to use is, really one of the key steps of data lake productivity. And then finally, you're going to need to present data to customers, as Gilad talked about. Whole host of tools there. But the thing to think about is really where you start out when you build your data lake today is not where you're going to be in the future as you're successful. So you want to build this kind of modularized architecture so you can evolve these different aspects as your use cases evolve, as you onboard new users, new use cases, new tools, so that you can really kind of evolve around your data foundation without fundamentally breaking what's working today, but making it additive. And to that point, the other thing you're going to want to do is really do a pipelined architecture. You don't throw everything into one S3 bucket and one big mass and operate against it. You're going to want to think pipeline and kind of segregating account privileges, security, management by stage of workflow, because they're going to have different requirements. So raw data in, you're obviously going to aggregate there. You're going to want to go through a cleansing, a normalization, a transformation, data checking process before you actually load it into ETL, and then ultimately into the production data lake. So you do those as stages. You try to orchestrate that as much as possible. And then if you have presentation layers, you can move the data out. This is going to make it easier to govern. It's going to keep your CISO happy, make it easy to manage your data, and ultimately make it more efficient so that you can kind of change each of these stages independent of the other as you evolve. Other considerations are think about data management at scale right from the get-go. Even if you're just starting out with a couple hundred terabytes, small amounts of data, I mean, you heard about the kind of data growth that AppsFlyer has been experiencing, and so you really have to plan for this up front so that it becomes ingrained, it becomes automated. You don't have to make a lot of changes as you scale. Once you think about it up front, plan for it, set it up. So one of the foundations is to use S3 object tagging. S3 supports mutable object tags, and those can be used to drive things like lifecycle management, data deletion policies, replication policies, and most importantly, very granular security policies. So get in the habit and think about how you can use that up front and use that to drive very granular policies. It's going to make your life easier as you scale. And then you can implement lifecycle policies or use intelligent tiering, but even then you may want to use lifecycle for data cleanup and deletion or archive to classes like Glacier or Deep Archive. Tagging can be onerous. We've had customers that wanted to retrofit it to their data lake, had millions to billions of objects, didn't quite know how to do it. So we built and released batch operations, which essentially is a managed job engine for S3 where you give it a manifest, it can perform actions, including, most importantly for data lakes, you can run Lambda functions with this. So you can give it a list of objects, give it a Lambda function to run, start a job with a single API action or through the console. It will go off and execute that job and give you a completion report. So it can really automate massive processing of data at scale with very little user interface and no custom code you have to write. So really, ultimately, you want to plan for rapid growth, be ready for it, and use the management tools to start to automate that and make it policy-driven. Another data ingest pattern is, whoops, sorry, I went backwards, is to optimize cost, to choose the right storage class. We have 6 storage classes available for S3. We've had a lot of people just use S3 standard because it was easy. But ultimately, back to the scaling factor, if you do that, you're spending a lot of extra money that you don't need to spend. You should think about how to use those storage classes. And a good way to start to consider this is to think of, back to that pipelined architecture, what stage of the workflow am I in, and start to set up bucket policies accordingly. So for raw data and ETL data, you're going to want to use S3 standard. On the raw data side, you may have a lot of small files, objects coming in. You may be doing a lot of, they're going to use them, maybe then delete them afterwards, so they may be short-lived, or you may want to batch them and archive them. But there's going to be a lot of activity there, so stick with standard, and you don't have to worry about object size or object retrieval rates or short-term deletes. Same thing for ETL. You're going to get that pattern where you may be doing aggregation, multiple passes through objects, smaller objects may be deleted. So that's also S3 standard squarely. For the production data lake, I think Gilad gave a great example of how intelligent tiering can be much more powerful than trying to use standard infrequent access write lifecycle policies, because you may have a lot of ad hoc access, like in the case of GDPR, where you have to go in and update objects, rewrite. So S3 standard saves you money without having to worry about managing retrieval rates and being cognizant of that. So that's really good for your primary production data lake. But then you may have use cases where you want to keep data online cool. You know it's going to be cold, very infrequently accessed. Either it's replication for either data distribution or DR, or it could be data you want to pull back for model training periodically. Don't want it to be asynchronous, so we have infrequent access or one zone are good fits for that. And then ultimately, you'll probably have historical data. And so Glacier and Deep Archive are great for that because you can pre-plan when you're going to restore that data. If you're just using it for compliance purposes or data protection purposes. And then another use case we've seen is people would, because of the cost, throw older data away or kind of selectively prune their data because they couldn't afford to keep it all. But with Deep Archive and the price point that's set, we're seeing people move to keep everything because you never know in the future when you may want to go back, develop new algorithms, have a broad corpus of historical data that you can use to retrain. And so Deep Archive can be a great fit for that. Next thing is, you're going to have data coming from a lot of different sources, so you really need to think about your ingest patterns and matching the right tools to the data types. I mean, obviously, we heard about the streaming ingest pipeline, real time, for things like recommendations, sentiment analysis, IoT, predictive analytics. So really, that's a key use case. We'll dig a little bit deeper into that one. Batch is also core to data lake workloads, particularly in areas like BI reporting, log analytics, usage optimization patterns if you're doing things like supply chain. And then ultimately, there may be a lot of bulk data. Either you've got on-premises environments, you're periodically batching it, you're acquiring new data sources from customers where you may be lifting it from remote locations, loading it in. So we got the tools there, and you might use that data for machine learning, model training, data discovery, data annotation type use cases. So a little more about batch, because that is, in spite of, one of the common misconceptions is, well, I've got all my databases, running all of my business apps throughout the business. Why do I need to kind of put that data in the data lake? But really the power is those may not go away, but if you can take that data, start to load it in, aggregate across it, add in different data sources, there's likely going to be value there. So some common ingest patterns for those, if you've got databases, data warehouses, either in AWS or on-prem, you can use AWS Glue. It has ODBC, JDBC connectors where it can pull the data out, actually do the transforms in flight, ETL, before it loads it into the data lake. Or you can use DMS, which is a database migration service, either to do a one-time migration or more typically do periodic syncs of data from the database directly into S3 in the data lake. For traditional business systems like ERP or CRM, a lot of you probably use data management, transformation tools. There's a whole host in our partner network, so you can run those ETL tools on EC2 instances. A lot of them have native connectors to S3, so that's a good way to pull those data sets in, particularly if you've got it all planned out and are doing that on-prem today. Or you can use SFTP if you're transferring from on-prem, also kind of a common on-prem workhorse for these type of batch data sets. Or if you have specific line of business apps, you could use our storage gateway family and store those natively as objects. So multiple ways to get batch data in to your data lake and start to process it. One of the things, though, when you're building a data ingest pipeline for batch, you really want it to be event-driven, because I talked about these different data sources as well as a whole host of others. That data is going to be arriving at very different velocities, and some of it may be trickling in constantly, other once every few hours, once a day, others maybe just periodic batch. So if you think about a data lake, and one of the key aspects is time to results, how fast can I get from raw data to actually processing that data and putting it to good use and getting insights from it. If you can kind of shorten the time from raw data coming in to data ready for use by your data scientist, that's a big win. So the way to do this is to start to set up pipelines that are driven by triggers and orchestrated by Lambda, so that now you can really set up intelligent policies that match the data types, customize it to the data types, automate it, use triggers, and then now your whole ingest pipeline becomes automated, where when new data arrives, you can maybe say every 1,000 objects, fire off a glue job to crawl that data, populate the catalog, orchestrate ETL, load it into the data lake. Once the ETL, you get a trigger, the ETL's done, update the job pipeline or step functions that you may have to actually go through and process that, and then maybe ultimately load it into something like Redshift for reporting. So you can really build these pipelines that are sophisticated, complex, and kind of match the data as it comes in without a lot of user intervention once you set it up. So this is also a big best practice, is CloudWatch events, AWS Lambda, pipeline orchestration. Real-time data ingestion, I think Gilad gave a really good example of that. You're typically going to have a split path here where you've got data streaming in, you want to get insights real-time. That's not what an S3 data lake is good at. It's good at processing massive amounts of data, but unless you've done a lot of building specialized secondary indexes, typically you're going to use that for more batch bulk processing. And you're going to use something like Spark or Kinesis Analytics or the combination of both for your streaming analytics. Get it into some type of high-performance presentation engine like DynamoDB so that you can get to insights as quickly as the data arrives as possible. But then at the same time, you're going to want to keep all those data assets that are coming in to do retrospective analysis. If you think of like a security analytics use case where you want to flag anomalies as quickly as possible, but then go back and do retrospective analytics of, did I see this pattern in the past that somehow I missed it because my real-time algorithm didn't catch it? You're going to want to capture all the data, probably aggregate it if it's log data, using something like Firehose to get it into bigger batches, bigger objects in S3 of time series. And then you can start to ETL it, make it available for ad hoc or periodic analysis. So we see a couple different common design patterns when people think about building a data lake. If you're already a sophisticated analytics user on-prem, you probably have Hadoop, you probably have a data warehouse, you may have developed a lot of custom applications, a lot of custom code that was purpose-built to your on-prem environment and what you're trying to do today using maybe just standard data warehouse and Apache Hadoop and other open source tools. If you want to start to use the cloud, which there are obviously a lot of benefits for that, the best approach may be to lift and shift, where you're just going to pick those tools up, run them on EC2 with EBS and kind of our native infrastructure services, and run those as self-managed environments. Use S3 as that data storage backend to replace like an HDFS file system for the bulk storage. That's often the most efficient way to move to the cloud because it's less disruption to a lot of the custom development you may have done around those open source tools. It also minimizes your application changes, but the downside is you're going to provision, manage it, and scale it yourself. You're going to have to monitor and manage availability and multi-AZ models and all of that, and you're going to own upgrades and versioning. So you're trading off expediency, less engineering development, and simplicity of moving with a heavier burden on the back end. But it's the right approach for some of our largest customers. We've certainly seen folks publicly like Pinterest, Netflix, Airbnb take this approach to get to the cloud. But the other pattern, if you're just starting out or you have the luxury to start to refactor, is to use our managed services. Things like EMR for managed, managed Hadoop. You can use Athena for ad hoc, Glue, obviously, for catalog and transform, Redshift Spectrum, and then you're really worried more about or focused on outcomes rather than managing all of the infrastructure, all the services, and everything that goes along with that. So you're focused on outcomes, not infrastructure. You can speed adoption of new capabilities and ultimately leverage our pace of innovation, which always feels pretty good when you hear Andy's keynote today that we're moving pretty fast. And then another approach is a hybrid between the two where you take the lift and shift, but if you use S3 as that storage foundation, it allows you to evolve around the data itself. And so it's really kind of a hybrid approach in the cloud, right? Where you use open source today, but then maybe you migrate it to managed services or bring in new capabilities like machine learning through SageMaker with the data in S3. And then finally, another approach which is becoming common for folks that don't have a data lake today is Lake Formation. It is an AWS capability that essentially uses blueprints based on the thousands or tens of thousands of customers that have built data lake to start to automate building a data lake and take it down to being able to build a secure data lake in days. So what you do is you set up blueprints for data ingestion, transformation of data. Most importantly, it simplifies security management, where it starts to coordinate roles, IAM permission, KMS, metadata views of, I'm going to give this user in this group one view of tables that he can use maybe Athena on, whereas if it's a data scientist, I'm going to give him a view of all of the tables stored in the data lake that he can use all of the tools on. So, it really helps simplify both the setup and the management and the ongoing usage of data lakes, particularly if you don't have a lot of experience in this area. So I'm going to switch gears now and talk about some performance best practices. And this is going to be probably a little maddeningly vague and not too detailed, because in general, S3 automatically scales performance as the load increases. So for the vast majority of analytic use cases, you don't need to do anything special to get scalable, transactional, and throughput performance. S3 kind of scales performance by prefixes, by your object prefixes. By default, you get 3,500 puts, 5,500 gets per prefix. If you're using the SDK, AWS SDK, which most common analytic tools do, it also scales horizontally, because that's the other key to AWS or S3 performance, is really horizontal parallel access. That's how you get scalable throughput to go along with those scalable transactions. So if you think about prefixes and the performance per prefix, if you have 10 prefixes, you'll get 55,000 reads. Obviously, if you have 100 prefixes, you'll get 550,000. And there are no limits to the number of prefixes in a bucket. So you can see how performance can scale massively. And this all happens as a background operation in S3. And so if some of you have used S3 for a long time, you'll probably remember a time when you had to worry about prefixes because we did hundreds of transactions per second. But for the vast majority of you now, given that the SDK is very good at hiding 503 responses, which are kind of S3 telling applications back off, I'm splitting a partition to essentially double performance on that namespace or that key namespace. It's all transparent to you. You don't have to worry about it if you use the SDK. So you should really only have to think about worrying about prefix and naming schemes if you have workloads that you know are going to be massively scalable in a very short amount of time, like maybe you've got a huge amount of batch data to ingest, or you maybe have specialized needs like huge number of list requests. But other than that, it's pretty much set it and forget it, and S3 will scale as your load scales. And this is kind of an example of this happening where autonomous driving use case, people were ingesting data. When they first started out, maybe fired up their bucket, they had 5 cars dumping data in. They were all dumping to the same prefix and throttled to 3,500 transactions total. But you can see that graph going up. That was S3 realizing that it was telling the applications back off through the SDK. And in the meantime, it was splitting those partitions into 5 separate partitions since it kind of split on the key names, and we had car numbers in the key names. And now you can see each car is getting 3,500 transactions per second. If they added 50 cars, same process would happen. So an example of how this all happens behind the curtains. Finally, use larger object sizes. At least 16 to 256 meg is a minimum. But for a lot of things like Athena, gigabyte plus sizes are even more efficient because it reduces the list, the metadata ops, and the job setup time. And you can do that through Kinesis or Glue or EMR and Spark. Also use Parquet or Orc or a splittable compressed format because that's going to give vast performance improvements for things that do a lot of data scanning, like Athena. And then finally, use caching where appropriate. Either EMR HDFS namespace, if you're doing a lot of iterative step functions, or Spark, DynamoDB or Elasticache for low latency data presentation, or CloudFront for distributing data. And then finally, consider S3 Select. That's a capability where you can push down a SQL query to S3, and it will scan the data, only return the scan results. And so it operates just like a standard S3 command, and EMR 518 on can actually use this for Hive, Presto, and Spark, and a lot of third-party folks like Databricks and open source Apache have adopted it as well. And we just introduced scan range queries, which back to scale through parallelism for large Parquet files can lead to a big performance boost. And then finally, we're seeing people build HPC data lakes where they're almost taking traditional HPC workloads with massive compute clusters, combining that with data lake workloads. And FSx for Lustre allows you to have a high-performance Lustre file system and pull data out of S3 on access, spin up a large compute cluster, operate on that data, spin it down, write it back to S3. So you're now bringing the best of both worlds together of HPC cluster-style computing, data lake, because when you look at use cases like genomics or autonomous driving or oil and gas, those are really the type of design patterns you see. So with that, I'm going to turn it over to Amy and talk about security best practices.
Oops. All right. I'm just going to hold this. All right. Save the best for last, security. All right, so we've been talking about your data lakes in terms of that pipeline that John described and you heard from Gilad talk about. So we're going to talk about what it actually looks like from a security perspective. You want your data lake to be the source of truth, right? So again, talking about access by all these different teams and accessible and taking in data from all these different sources. But you also want to make sure it's secure as you're doing all of this. So we're going to talk about some best practices around how you secure your input sources, supporting access for all those different teams that you have within your company, and making sure that those teams, that they're only accessing the data that they should be accessing and privatizing the data that you have within your data lakes. So Looking at a sample architecture that some of you might have, in this scenario, we have an application that's generating a lot of real-time data, could be clickstream data, and sending it to Kinesis and sending it into your data lake. You have some vendor data out there as well that you want to put into your data lakes, and finally, you have some buckets. We were talking about our data engineering team and your security team. So what does that all mean? So the first thing you want to do is privatize your data lake. Make it anonymous. Deny access as a default. So this is done simply using S3 block public access. It has only 4 security settings that you can use to deny public access. You can use it at the account level or bucket level, and you can integrate it with AWS organizations, service control policies, or SCP to prevent setting changes. And then on top of this, yesterday we announced S3 IAM Access Analyzer in support for S3 buckets. And so what it will do is it will continuously monitor your buckets to see whether or not you have data that is open to the public, or if you've configured policies that might be something that doesn't look correct. And so it'll send you alerts to let you know, hey, you may want to check in on this. This doesn't look right. And if you had any questions about this was actually the link to our public documentation. Talk to your account SA if you have any questions or read up about it. Highly recommend this. So the next thing you want to do with your data lake is you want to encrypt all of your data. So we talked about how you privatized your data. Now we want to ensure the data within your data lake itself is also secure. So S3 supports encryption. There's encryption in transit when you're sending the data. We support HTTPS and TLS, and you can also use your bucket policies to ensure that you are taking it in encryption. Encryption at rest. So we support both server-side and client-side encryption. On the server side, we can do the management of the keys for you with Amazon S3 managed keys. We can use KMS or key management services to manage your keys, or if you prefer, you can also provide your own keys. Client-side encryption basically means that you're encrypting your data before it enters S3. So with that, you want to leverage the AWS encryption SDK. And again, encryption, if you want to read more documentation, that's also a quick link to where you can find out more information. And the best thing is you can just turn encryption on by default for your S3 buckets. So this is for server-side encryption. If you have any doubt, just turn it on. Make sure that any data that enters that bucket, so any objects as stored within the bucket that has it turned on by default will always be encrypted. That way, it guarantees that you stay compliant. So after you've encrypted your data, you want to make sure that you've secured your data from the various input sources. So we're going to take a small detour and talk about AWS identity and access management terms. So IAM is a free service that we provide, and it is the authentication and authorization service that we have. You can use it to define who can access your services within AWS, so that's the authentication part, and what they can do, how they can do it, and that's the authorization aspect. So your principals are your users, your roles, your applications. These are the things that will be performing your actions. So your principals, your first principal that you have can be your root account when you create your AWS account. So after your principals, the other thing I just want to cover really quickly are your resources. So this could be your S3 bucket, objects, your EMR instances, different things like that. So the difference between an IAM user policy versus a bucket policy. So IAM answers the question, what can this user do? Versus a bucket policy answers, who can access this S3 resource? So IAM policies, by default, there is no permission. You can use this across all of your AWS services, and you maintain control within your IAM environment. Versus for your S3 resource, it's about your S3 environment, and your buckets are private by default. So putting it all together, this is what things would look like once you've locked things down. And on top of this, what you also want to do is enable cloud trails. So that way you can manage all the auditing of your API access to your data. And then you want to store it within your logs bucket as well. So an example for your bucket policy for your data lake is enabling third-party vendor access. So we talked about that vendor data, right? So maybe you went out there and you said, there's some social media data out there, we don't want to actually manage it, so we're going to buy it from a vendor. And so we want to let them automatically store it within our bucket, within our data lake. We don't want to have to deal with the actual ingest ourselves. So what you would do for your bucket policy is you would define your principal for that third-party vendor's account ID, and you want to allow them to put or store the data within your resource of the DigiRoad bucket. And then if you want, you can put a condition on there as to how, when you want them to allow them to do this. And so in this particular instance, the bucket owner has full control. So finally, you also want to talk about who can access your buckets and what they can access, right? So AWS Organizations is a centralized control that you can use to replicate your policy templates across your organizations. So AWS Organizations is essentially, it takes the assumption that any company is an organization and you're going to have teams or organizational units, lines of businesses over there. So they say you can define your policies across your different OUs and then just replicate your permissions out. And the best part about AWS Organizations is to essentially manage cost and billing, because your data lake is going to be used by different OUs, different lines of businesses, and it allows them to do bill back. So IAM policies for your data lake. You want to make sure that Kinesis could put into that mobile ordering bucket. For giving teams access, you want to talk about maybe your data engineering team needs to only read the data within the mobile ordering or the DigiRoad bucket, versus your security team will want to access the logs bucket. And again, for both of those teams, you only want to allow them to read the data, but you want the data to not be changed. So altogether, this is what your data lake would look like, applying those best practices together. So what happens if your data lake has a lot more data? Your company has grown, you've developed more applications, hundreds of applications. You've grown your organization, you've added more teams, you maybe had a merger with a company, something like that. And now you have all these different teams around the world wanting to access data, and you're starting to find it more difficult to define a much more granular access to your data. So let's talk about what it would look like for a shared bucket within your data lake. So in this particular example, for the mobile ordering bucket, you might want your finance team going in there and reading the revenue data. Your sales team wants to obviously look at who is accessing the data so that way they understand what customers are doing, purchasing in there, and your data science team wants to be able to access all that information, right? So they can take that data, do some pre-processing, run some analytics or machine learning on all of that data. But you have lines everywhere, and in this scenario, in this world, there's a single bucket policy, right? For all these different teams of different types. So every time you're adding a team, you're adding a user, you're adding an application to this single shared bucket, your admin has to go in and update that bucket policy to say, I'm letting this person in, and it gets a lot more difficult. And maybe you're adding so many different lines into your JSON file that you found that you hit that 20K limit. So it's difficult. So today, we announced S3 access points. So it's simplified control for shared access for many teams. So what it does is it enables you to segment your teams into distinct groups. So we talked about your finance and sales and data engineering team. So each of these groups now, you're going to define their own access point for them. So they're going to get their own bucket names in there. So this will be a combination of a bucket name that'll be unique to them. At a super high level, you could say maybe each of them will get their own test bucket. I don't know why a finance team would need a test bucket, but let's just say they did, right? So they could all have their own test buckets that's unique to their region and to their bucket. And then you can apply a policy for each of those access points to them, tailor those permissions in. And again, we were talking about how the finance team would only need to access the revenue data, and the sales team would only access the customer data, and the data engineering team would only be accessing data for the BI relevance. And so it allows you to have that maintain the centralized control across your overall storage. So you can have many access points for a single bucket. And then it allows you to have a lot of different policies for each of those access points tailored for each of those different groups. So if you want to hear more, I'm going to cover this a little bit more, but there is going to be a chalk talk tomorrow on access points. So what did that shared bucket look like with access points? So in this scenario, you can see here, you've created an access point for your finance team, and you want that finance team to be able to read and write data for their access point only, and we've attached a policy to it, versus the data science team. They're gonna wanna only access data that has been tagged BI, and so we only want them to read the data, not to actually change the data in there. So in this aspect, you don't have to change all the different files every single time. You can just say, anyone who joins your data science team is going to be added to this access point. They'll be given the ability to use that to access the data instead. So some takeaways from all of today, from this past hour, I guess I should say. So S3 is the ideal foundation for your data lake. We've heard from how AppsFlyer covered how they leveraged it. You want to leverage that pipeline architecture to improve your data governance. It helps with your entire workflow and helps with your efficiency. You can improve your performance by parallelizing access and scaling horizontally. You want to make sure that your data lake is private, encrypt everything, specify specific access for your data lakes. You can run using the S3 Access Analyzer to see what is open to the public. And finally, simplify the control for your shared bucket access for all your different teams using the data lake using S3 access points. So we covered a lot of different topics in this hour, and we probably didn't get as deep as you would have liked us to, and we recognize that because of all the topics that you have within data lakes. So I've selected a few breakout sessions or just sessions in general related. So at the top in green, those are other data lake sessions. The next section will be deep dive on security, so if you're interested in that. If you want to learn more about S3 access points, we have a chalk talk and a builder session specifically on access points. And finally, we have a chalk talk about performance. So the last best practice I'd like to leave you is, you probably have received alert or will be receiving alert. And to get rid of that alert, the number 5. We would appreciate if you would complete the session survey and just click 5s across the board. Let us know that you found this interesting, that you learned something from tonight, that you hopefully found today interesting, and you had a great time on Tuesday at reInvent. So you've got the rest of the week. Hope you have fun. I hope you guys have a great rest of your night, and thank you for being our attendees in the last session of the night.